First, couple announcements. One, homework's due. Didn't bring a stapler, sorry. See if you can borrow one from someone else. Second, today's just a review session. If you have any questions, there will be an opening statement or a correction, and then we can do whatever we want to do. Tomorrow, 6 o'clock in here. What did I say yesterday? Yeah, that place. And we'll start at 6. Small possibility. I am interviewing for the MSMS physics position. It could run late. I doubt it. We've scheduled extra time to get back from Columbus. So unless we accidentally pass into Starkville and we get captured by pirates, we should get back fine. Thursday, as a reminder, Thursday morning and Wednesday night, I will remind you, we will red out on test 3. Wear red. I've got my shirt all picked out. I want it to be blood red. We're going to take pictures. May even do a little bit of a rally right before. Just to get us all pumped up for the test. I want to do it on the final, but finals are too big of a deal. I don't want to get you guys totally weirded out. As long as there's points. There has been a rumor, and I can neither confirm or deny it. If everyone wears red, I will consider opponents. Maybe not 10. But the deal is this. If I see anyone, now I promise it won't be me. I'll wear red shirt, I promise. But if anyone is not wearing a red shirt, heels off. So I joke with some people that they will actually bring extra red shirts to the event. So I want this to happen. Think of it as a party gift to me. It's kind of like, I know my life's doomed here, so I'm going to ask for certain favors on my way out. On number 1 and 6 of problem set 9, there is a correction that I want you guys to know. So, on Blackboard, there is the odd, destructive, and constructive. And there's the not odd, destructive, and constructive. So for not odd, and if anybody has come up with a mnemonic or some way to really understand what's going on with this stuff. What did I do? Not odd, hold on. Even I get them turned around. Hold on, I'm getting off. Basically, it's this. For a thin film, air, gas, and water, that's a 2 shift. So this is not odd. This is an air, soap, air, so there's 1 there but not there, so this is definitely odd. So that's the odd one. Excuse me. Can we do it correctly? No. The thing is when we calculated the thickness of the film, if the film, middle film, is air, such as what we have is, well, none of these, either one of these. You use an index of refraction of 1. So you just dump the ends because n is 1 and it doesn't really matter. But in any calculation of the thickness, you must include the n of the middle substance. Let me say it again because it's a correction. In any of the thin film problems, memorize these equations with the ends and you will never fail. And then you go, well, what's the index of refraction of the middle? Well, it's air. Oh, well then n is 1. Is it water? Oh, it's 1.33. Is it gas? It's whatever I say it is. And so get those straightened out. In 1 and 6, I was playing with something else, and I was more interested in getting something else right, and I forgot that. In the calculation of number 6, where you figure out M1 and M2, what do we do? It's the same thickness, so 2t is equal to 2t, and you put them together. On one side you have lambda 1 over n, on the other side you have lambda 2 over n. Those n's cancel. So the actual m values are correct. But when you go back and calculate the thickness, you have to have that n value under the lambda. It is a very common error. So it's one of those things where probably if you miss it, it'll be like 3-4 points off the problem. Technically, there's never a time where you don't divide by it. But yeah, but a lot of times that middle substance is air, and you just forget about it. And that's the one thing. Yes. You're running in what? Or because here's the deal. In the setup of problem number 6, they both appear bright. So it's an odd. So odd constructives you get this. You set the thicknesses equal to each other. There is one problem out there where I say one is bright and the other is dark. In that particular case, the bright you would use this, the dark you would use just m lambda over n, but they both use the same thickness. So you set them equal to each other. Now to address the problem or the question that was asked, it's the same middle substance. Not only is the same thickness, it's the same material. So those ends are identical. So in the calculations of the M1 and M2, technically n doesn't matter. It's not index of refraction dependent in order to determine the m's. But to determine the thickness, you go back and you take the M1, plug it in there, and then you get your thickness. But you have to have that in. The middle end thickness, yes. Most likely, and here's the deal with the test, that material is not going to be air. It's going to be something else. So really, I'm kind of rewarding the people who are in the room that I'm basically going again and again and again and again. Remember to divide that lambda by n. Now, had you put it in this and plugged and chugged away, it wouldn't matter because it would be consistently canceling each other. And it would, I mean, I guess you could leave it in just to play it safe. But in terms of the actual calculation of the M's, it has nothing to do with it. Yes.
It says the projector's overheating.
I think the problem is they left it on overnight. If I turn it off, the lecture effectively ends. So we're gonna let it run. Oh, go ahead, Adrian. I think it was number 1 and number 6 that I left out there. Did I get what? For number 1. Yeah. That one's easy. You just use 1 and 3. Probably the two things that you need to remember is how I would probably do it is I would set, like, I know for a fact that convex lenses have positive focal length, and so if I go convex to concave, I flip the focal length. If I go from lens to mirror, I flip the focal length. I'd probably go odd constructive as the M plus 1/2. And if I go anywhere in the box, then I flip the M plus 1/2. I have no mnemonic for this. I've got mnemonics for colors of resistors, but for other stuff I don't. Yeah. N equals what? It depends. Now, soap bubble means that we have an odd situation. Soap goes air, soap, air. Low to high, phase change. High to low, no phase change. So we got an odd. Maximum reflectance. That thing constructively interferes. So we're looking for an odd constructive, which is this equation right here. Now, we're looking for minimum thickness, and I'm answering your question. I think you know the answer, but everyone else in the room needs to know. Because it's M plus 1/2, 0 is an allowable index. So therefore, M in this case is 0. If it was odd destructive, where you've got 2t equals m lambda over n, always remember your n. I'm going to keep saying it just for my benefit, not for yours. In that case, the m lambda over n, m equals 0 is an unacceptable value because thickness would then be 0. And you can't have anything, if it has no thickness, it doesn't really exist. And that's for a philosophy class. If a bubble has no thickness, is it still a bubble? I don't know. I don't care. So m is 1 in that case. But for constructive odd, m plus 1/2, m is 0. All right. Any other questions about this thing? Once again, always put in the n. Lambda in a material is lambda in a vacuum divided by n. We've kind of proven that, so I think that's a given. All right, anything else? Yes? Yeah, multiple choice.
Multiple choice.
Well, what?
Okay, I have a question about a problem, like the word problem. Problem 2 on summer 16.
Okay. Which version do you have?
It doesn't matter.
Alpha. We're doing alpha. Now what? What the problem that I did in the problem that I hold on, this is, are we talking summer 15 or spring 15?
Summer.
Summer 15. Well, we did summer 15 in tutorial.
Oh, okay.
Hold on. Let me make, he seems to be on it. Is this the one that we did last time? We did spring 15? We did spring 15. Oh, you did that, we did that. Okay. That's what I thought. So we did. Are you wanting to do something out of this? The one with the handwriting or with no handwriting? Look at the top of the page. It should give the semester. Summer 15. Okay, that's it. All right, now we're dialed in. Okay, this will be version alpha. The spring 15 also had versions of alpha, beta, gamma. I was very uncreative. And I'll tell you why we don't do that anymore. It's because, not saying you guys cheat, but there was some heavy cheating. Because I would go alpha, beta, gamma, not saying you. She would hold on to 2 alphas. You would hold on to 2 betas. You would give your neighbor an alpha. You would give your neighbor a beta. And it would continue backwards. And I couldn't figure it out for about 2 years. Then I sat there and watched. I'm like, I know for a fact that there were 12 tests in here and only 10 got distributed, which means some tests meander. So that's how I figured it out. So now it's basically I take the test and I shuffle it like a deck of cards. All right, summer 15 alpha version. Compound lens has a magnification, total magnification of what? B. It's the product. Convert 2 meters into angstroms. A. Which is an invalid value for the index of refraction? A. Index of refraction can never be negative. Index of refraction can never be less than 1. Single slit experiment demonstrates what? Diffraction. Now, refraction is a product of what? Like, where does it occur most often? Lenses. Stuff where it has to pass through a medium. Reflection is demonstrated by what? Mirrors. Inversion is demonstrated by what? Thin films. It's things that invert when they bounce off an index higher than it's traveling through. Vacuum's wavelength 500 nanometers. Passes into glass. Index is given. What is its new wavelength? D 250. What? Yes. Can I explain what? Number 4. So, reflection is the act of light bouncing off a surface. Diffraction is the action of light, or I'm sorry, refraction is the act of light passing through a medium and bending. Refraction, or diffraction, is the process of light interfering with itself after passing through a slit or slits. Inversion is light bouncing off a medium and inverting its phase. changing. Yeah. Single slit, double slit, diffraction grading, all refraction or diffraction. See, I didn't remember. I just remember reflection, refraction, bouncing off and passing through. Diffraction is that other weird one. And then inversions is something extra. The angle of refraction is at what value when the incident light is at its critical angle? It's 90, yes. Light passes from water to glass. Which of the following is false? Should be B. As I've said before, frequency of light never changes. End of discussion. Image behind the mirror, the image distance is what? Less than 0. Double slit experiment. As the distance between the slits decrease, all values constant, all other values constant. The distance from the central max to the max on the either side. Now for this, so as this distance decreases, in order to maintain this constant, L must increase. So the distance increases. So when you look at this, L is m lambda over d with the big L up top. So as this value gets smaller, that value gets bigger. Your single slit experiment is now underwater. How is its new diffraction pattern different from the pattern when the experiment was in air? So for this case, it's d sine theta equals m lambda over n, or d L over big L, m lambda over n, or L is m lambda big L over dn. So as the index of refraction increases, L decreases. So the minima are closer together. For a diffraction grating, which of the following is true? B. Diffraction gratings are concerned only with maxima. The units of magnification are no units. Now, M is the symbol that represents magnification, but those aren't the units. A diopter is also known as what? B. I will be looking for this. I will be trying to find individuals, such as the individual who is not seated in 32, someone who has never attended class or watched my video. I'm going to catch them. Yeah.
What do diopters pertain to?
What do what?
Diopters pertain to?
Diopters pertain to the focal length of the lens or mirror. So for single slit, the equation we use is for minima only. For double slit, it's for min and max. We have two equations for that. For diffraction grating, It's for max only. For min only, we get this very nice thing, and we're only concerned about the dark spots. For diffraction grading, we get this jumble. I'm sorry, double slit. For diffraction grading, we get spikes. Kind of pointless to look at the minima for this because they're just, can't really tell. You have a lens diverging 8D. What is the focal length of the lens? It's B. Now the focal length magnitude is just 1/8. But it's a diverging lens. So diverging implies that the focal length is negative. The information of the focal length is given by the word diverging. In a single slit experiment, which of the following is true? It's D. Single slit, 1, 2, 3. Double slit for both 0, 1, 2. Diffraction grading 0, 1, 2. The mins work with 0 only because there's an m plus 1/2 in the equation. Two rays of light in vacuum are compared. One has a higher frequency than blank wavelength. What is blank? It has a shorter. Your image distance is negative. Your image is virtual. Now it could be that the image is inverted or enlarged or reduced or whatever, but by the fact that it's negative, it is definitely virtual. The images that appear on the back of your eye are inverted. What is the frequency of 2000 gigahertz light in glass? 2000. Light in a vacuum reflects off of glass. The light experiences a phase shift of C, lambda over 2, half a wavelength. Yes? Say that again. For the single slit, it doesn't exist because you wouldn't get, it's not allowed. Half a wavelength. In other words, what's the phase shift of light bouncing off of glass from the vacuum? 180 degrees. That's the phase change. 180 degrees is half a wavelength.
Could you also consider like ambient or not ambient? Is that what you're saying?
Well, the point of the question was light was bouncing off of glass. The wavelength is already, it's traveling from vacuum to glass, so in is 1, and I'm not really interested in that. The fact that it bounced off glass means that the phase change, there is a phase change of 180 degrees, or lambda over 2. Lambda over 2 and 180 degrees are synonyms. When parallel light, oh my goodness, my voice is going to crack, interacts with a convex lens, the light rays do what? They refract too. 22, upright enlarged, which is right? C. Magnification positive 0.4. Reduced and upright. Convex mirrors are known as diverging. Unpolarized light passes through a single polarization filter. What is the new intensity? Now there was another, I think it was in problem set 8, where I thought the light entering the polarizing filter was unpolarized, but it was polarized. There was a mistake in that. But that's the multiple choice, test 3. All right, let's do this. Where's my paper? There we go. Okie dokie. Initial light unpolarized, final light is 29% of original light. What? Well, hold on. There we go. So, stage 1 gives us this. The initial light is unpolarized. It is definitely a legitimate question to ask, is the initial light polarized or unpolarized? It's quite clear that the initial is unpolarized. I2, because we now have unpolarized, is I1 cosine squared theta. Performing a substitution, I2 is I0 over 2 cosine squared theta. Now we're given the information that I2 over I0, which is equal to cosine squared theta over 2, is equal to 0.29. Solve for theta. 0.29 times 2 is equal to cosine squared theta. Square root of 2 times 0.29 is equal to cosine of theta. And inverse cosine of square root of 2 times 0.29 is equal to theta. What? 1. This should be in degrees. Well, if you got 1, it's probably 1 radian. And 1 radian is 40.4 degrees. No, 1 radian, yeah. Is what? I would say it's a safe bet. There was at one point, the way that I did things, it was required that it be in radians. That time is gone. Keep your calculator in degrees and you won't go wrong with this. Object is always left of the optical object. Given O and M, what is the focal length? Oh, I got tricky. So O is 0, well, we're going to keep everything in centimeters. For lenses and mirror problems, keep it in centimeters. Yes? Initially, the last sentence in the appetizer says the initial light is unpolarized. What? I'm going to be very specific on the problem. I'll either say initially it is polarized or unpolarized, or I will say don't know. I haven't figured out about that part. Don't ask about that. This is not the problem we're going to say.
So what if it was polarized?
Huh? If it was polarized, you would do it. Okay, let's do that. Let's say the light was initially polarized and the final intensity was 0.29. Well, we would have, oh, whoa. Yeah, it's still doable. I1 is this. I would have to give you more information. I would have to give you 3 of the 4. I'd have to give you something like that, and I'm not. I'd have to give you the information. I'd have to give you a lot. I'm feeling. Now notice, what have I always said about Dr. Eschenberg when he says something like, "I'm not feeling really comfortable with this type of problem." It's like when I touch it, it burns my hands a little bit. I don't want to. If I'm getting a little bit uncertain about it, you guys are just going to go nuts. This is valid. That's, though intellectually interesting, I don't think I'd do that. So object is 20. M is -2. So if M is -2 and I got the object distance, I know M is -I over O. Or I is -MO, or negative of a -2, object 20. So the image is +40. I know it's a mirror, because I say so. Image distance is +40. Therefore, it's on a mirror. It is left. It is real. Magnification means it is inverted and enlarged. 1 over F is 1 over O plus 1 over I. F is 1 over O plus 1 over I. Inverted. That means 1 over O, 20, plus 1 over 40 means I'm going to have a focal length of positive 13.3 centimeters. Since it's a mirror, since the focal length is positive, it is a concave mirror or a converging mirror. Now, I didn't bring my ruler, so we're going to kind of ham-handed do this. Bring a rule. Actually, let me tell you. Let's say for a moment, oh dang, I forgot my ruler. How I would do it, I just get a sheet of paper and do it like this. Now it's not going to be beautiful or perfect, but it'll get the job done. Let's see, object 20, focal length 13, image 40. So let's say image is 40 out here. Object is half the distance, or 20 here. Focal length is 13.33, so we'll approximately put it there. So there we go. F prime is there. Magnification is -2. So object height, I'll just use the height that I used for the focal length. Image distance, I'll use twice as that, and I'll invert it. So there we go. Now, follow the 3 rays, 1 through the middle. Two starts parallel. Gets bent through focal point and the image. Third ray. Third ray, I've decided from now on, it's not a cheat, I just know how it looks like, so I'm going to do the ray first, so I know how it looks. And then when I go, well, this is parallel, how do I line up that with that? Then I just connect the dots. So that takes the difficulty out of drawing that third ray, which tends to be a bit of a bother. And there you go. On the test, only 2. On the test, only 2. You have my word. Huh? Only 2.
It is expressed here through the focal point.
Yeah, it's kind of off. Big deal. Yeah. All right, now let me go. What do I know about my students? You guys would sit over a sewer drain and try to crawl out, dig out a quarter while $20 bills would fly over your head. It was your quarter, yeah. But the lens diagram, its purpose is this. Did you draw the image correctly that's associated with the magnification? We got a magnification of -2. If you draw that image upright, the graders are going to come at you. If you draw that image reduced, and it's obviously enlarged, we're coming at you. Do the rays kind of get into the region that it should be? Yes. We're not, this is not art class. We are not looking for artistic perfection. It is definitely not architecture school where everything has to be lined up beautifully. We just have to communicate the gist of it. But for the most part, you can almost not get this thing wrong. We only deduct points when you make horrific errors by not understanding what the M means with respect to the image drawn. Yes? I can't hear you. Dotted lines are not necessary. It depends on the situation. If you want to talk about it. But as long as sometimes dotted lines are necessary, draw in the case of virtual image. It is necessary. But in this particular case, the images are, the dotted rays are not necessary. So it's okay. Excuse me. Oh, number 2. At last, we meet again. Double slit experiment. Boom, write it out. Pa, for you here? Ooh. Don't tell anyone I did this in the video. No points for you, Pa. All right, continuing on. We have the double slit. Which one is constructive, which one is destructive? Left is constructive, right is destructive. What are the acceptable M's?
Any values of positive
And 0, correct. So 0 is acceptable for both this and this. When you're drawing this, the constructive I'm going to draw on top, destructive on the bottom. 0, 1, 1, 2, 2, etc. 0, 0, 1, 1, 2, 2. Why do I what? Well, M is equal to 1 and used in both cases. You mean Y is not the central band labeled 1? For thickness. Oh, yeah. Get it. Yes. M's always do have to be in it.
only has always running a 1 and single slit.
If it's a single slit, you don't search it. I can't tell you how excited I get when I see it. It lets me know. Also, I do love this. I would say in thin film situations where you're only dealing with M and not M plus 1/2, M cannot be 0. In single slit, M can never be 0. In double slit and diffraction grading, M is allowed to be 0. Yeah, we were doing thin films earlier. Well, I'm kind of describing the situation at hand, because the problem is the maxima are constructive, destructive are the minima. The question is going to be, give me the number of bands. Give me the total number of bands, bright and dark. One of the things about a double slit, true or false, the number of dark bands are odd. False. Number of dark bands are always even because you start 0, 0, 1, 1, 2, 2, etc. The number of bright bands are always odd. Double slit. There was another question in there. All right. So the question is, there is a region on either side where those L's are 10 millimeters. The lambda is 700 nanometers. The big L is 3. The little d is 3 millimeters. And I need to know the total number of bright bands, the M for destructive, the M for constructive, and then I got to determine the total number of bands. So we're all dealing with air. This double slit's not in air, so I don't have to worry about the index of refraction. Well, I do, but it's 1, so it doesn't really matter.
So if it wasn't in air?
If it was in a dunk tank, you would just take in and or lambda and divide by n. I don't know. I haven't written the test.
Is that a viable question?
It is a viable question. Remember, we just answered it in the multiple choice. But it's not a big deal. What do? You just change lambda over n and run with it. It's not... Ugh. So now... using the small angle theory, or small angle, d sine theta is tan theta is L over big L, and this is M lambda, and we're gonna do this right now for constructive. Actually, I'll do it for both. dL over big L. M plus 1/2 lambda dl over L lambda M plus 1/2 dl over L lambda minus 1/2 is equal to M. So this is M for destructive. This is dl over lambda L is M constructive. So you could effectively say that M destructive is M constructive minus 1/2. Do the substitution. Plug in values. Little d, 3 times 10 to the negative 3. Little l is 10 times 10 to the negative 3. Now, why did I not use 20 millimeters instead of why did I not use 20, but rather 10? The L that we use in the equation is from the central max outward. And I was very specific to say that that region was 10 millimeters. The total region was 20. But in your calculations, you only use 10. Lambda, 700 times 10 to the negative 9, and then 3. Cancel, 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 cancel 10 to the negative 3. And I'm left with 10 divided by 700 exponent negative 3, or 10 to the negative 3. And I'm left with M constructive currently of 14.28, which means 14.28 minus 0.5 is equal to 13.78. That's, you use the entire number to calculate the M's. But when you start counting bands and you start defining what the M values are, round down. Always round down. You can either have a band or not a band. You cannot have a fraction of a band. So M constructive is 14. M destructive is 13. Now when we look at this, given the number of M's in the bright band, you can put together that the number of bright is equal to 2 times M bright plus 1. If MB was 0, plus 1 means one band only. If M is 1, 2 times 1 is 2, plus 1 is 3. So this is number of bright 2 times 14 plus 1, or 29. For destructive, if M destructive is 0, you've got 2. If M is 1, you've got 4. So the number of dark bands is M dark plus 1 quantity 2. So the number of dark is 13 plus 1 times 2, or 28, for a total of 57.
So always one less dark than bright.
Typically. Well, it really, actually, no, I'll take that back. It depends on where that band,
That's all.
where it cuts off, yeah. Because here, if it cut off there, just on the other side of the second dark band, or M equals 2 dark band, you would have more dark than bright. It's not a given. Most, either A, it will be 1 less, or B, it will be 1 more.
Are those like what you said, like they get the total band? Is that always true? That,
For these, yes.
okay, just check like.
Yeah,
just
for
make
the-
sure it wasn't situational.
No, for the number of bands in a double slit, those are the 2 equations that you'll put together. Okay, problem 3. Dr. Eschenberg, please remember to include in when you have your lambda. We won't want to make a mistake like you've done repeatedly today. Okay. Now, one of the things that the students griped on was they sat there and they said, you didn't give us the index of refraction of oil. Well, had you looked at the equation sheet at the front of the test, I do give it right there, 1.2. So, I think it's a fair question to ask, but it was given. Hold on. All right, 1 to 1.2 is a raise, so that has a phase change. 1.2 to 1.33, that's another phase change. So we're dealing with a not odd. So for not odd constructive, 2t equals m lambda over n. For destructive, it is a 2t m plus 1/2 lambda over n. Now in this problem, it says that lambda 1 constructively interferes. So that will be lambda 1 and that will be m1. Lambda 2 destructively interferes, lambda 2 and m2. It's the same material. The indexes of refraction are both 1.2. The thicknesses are the same. So I can write m2 plus 1/2 lambda over 2, or I'm sorry, lambda 2 over n equals m1 lambda 1 over n. they're the same material, so the ends cancel. Now rearranging this, I get M2 plus 1/2 lambda 2 over lambda 1 is equal to M1. I need to factor out, or need to get to a point where I can solve for one of the M's. What I will do is now construct a chart M2 can be a valid number of 0. So 0 plus 1/2, and here, one of the things that I do, lambda 2 is 1400, lambda 1, oh, I'm sorry, I got it reversed. Lambda 2 is 800, lambda 1 is 1400, 8/14. Is 4/7. So when M2 is 0, 0 plus 1/2 is 1/2. 1/2 times 4/7 is 2/7. That is not an allowable number. 1 plus 1/2 is 3/2. 3/2 times 4/7 is 6/7. That's not allowed. 2 plus 1/2 is 5/2. This leaves you with 10/7. And 3 makes it 7/2. 7/2 times 4/7 is 2. There will not be, I'll keep it to either, one of the solutions will be either 1, 2, or 3, and we're not going to go to like 25. Now that I have M1 and M2, I can use either one. Remembering to keep my N value in it, we wouldn't want to mess this up at the last moment. So I'm going to use constructive. 2t equals M1 lambda 1 over N. So t is M1 lambda 1 over 2N. My M1 is 2. My lambda 1 is 1400. Oh, there we go. There's a 2. And then my N, I use 1.2.
Should always use the middle one.
Yes. And hold on. 1, 1, 6, 7. The reason why you use the index of refraction of the middle material is because that thing is oscillating at a specific wavelength within that material. What you're trying to do is compare the phase of the light that's bouncing off the first medium with the light that's coming through that 2T. That 2T is dependent upon the wavelength. That wavelength is dependent upon the material in the middle through which it's traveling. So you have to use the index of refraction of the middle material.
But you could do the same thing for M2 and lambda 2.
Yeah, you would get the same answer. I could just on the slide give frequency, but oh, did I ask for that? Oh, okay. What is the frequency of the light in the oil? To get the frequency of light in the oil, all I have to use is the wavelength of light in a vacuum. So that's 3 times 10 to the 8th divided by lambda 1, which is 1400 times 10 to the negative 9. And that'll give me the frequency. Well, why don't you take into consideration the fact that it's traveling through oil? Frequency is a constant. It doesn't matter. What you would have to do is you would have to adjust the C, take into account the index of refraction, and then stuff would end up canceling out. When I deal with frequencies, I always use the lambda in a vacuum, because all you got to do is you got to take speed of light divided by the wavelength in vacuum, and then you got frequency forever. Doesn't matter what material. All right, tomorrow, tutorial 6 o'clock over there.